We're here at the ETG Tech Centre in front of a Quaser machine, and Chloe's going to show me how to create a pocket on a Heidenhain control. Is that right, Chloe?
Yeah, 100%. I'm going to show you how easy it is, she says, to create a pocket in just a bit of aluminium or something like that.
Brilliant. You've not run through this before, have you yet? Not
no,
today,
so
anyway.
We've just done this. I've been off the tools for about a year. So for me to pick it back up quite easily, we'll show you how easy it is.
How easy it is for anyone to pick up how to make it right then. Let's get started. So what do we do first?
So I'm in the program management. All we've done is press this button here, and we're going to create a brand new file starting from the beginning. So what we're going to do is we're going to come across, making sure you're in the edit mode, right? And you're going to come across to new file. What we're going to call it? Should we just call it Rowan?
Let's call it Rowan. If you want, yep, perfect.
So,
no, I'm not doing this. You're showing me.
Rowan, okay. I'll show Rowan how to do it. So click OK, and obviously this Quaser UX500 has got the touchscreen control.
Yeah, which is obviously a lot easier than having to go in, enter.
And if someone spilt tea over your control, you can go. So it's going to put us in, you want to be millimetres or inches. We want to be millimetres, don't we?
Yeah.
Okay, so it's going to come up. We're going to pick whether we've got a
square stock, round stock. It's pretty obvious, isn't it? Shall I pick square stock?
Yeah, so
brilliant.
So Z means that's the Z plane that the tool's coming down. So what we'll do is we'll press enter. So X, this is your, so it says somewhere your minimum, so it will be 0. I always like to work with my X0, Y0 on the bottom left-hand corner. That's how I've done it. And I always stop at Z0. Anything that's in the material will be Z minus. Anything that's above the material will be Z plus.
Right, okay.
So if it's minus, you're cutting into the material. If you're plus, you're away. So we'll do that. We'll do 0, and then we'll go Z. We'll say the material
starts at minus 50, for example.
Yeah, so we'll be 50. Because obviously minus is smaller than 0, isn't it? So we'll go next. It then takes you next to your block form. So what's your maximum? So we'll do 150 by 150 square. Yeah. Right? And then your Z0, because that's your top limit.
Okay, I can see it tells you exactly what it's asking for, just in the top bit here.
And if you want to go back, it will always tell you, right, what are you doing?
And this got me, when I first started using Heidenhain, to go back, you have to press left inside the line, don't you?
Yeah.
If you press up, you'll go up a line, so you'll go into the next command.
Yeah, 100%. So you're always working back on yourself. So you're always remember your Z as well, because that's the axis your tool is going to be in. If you haven't got that, it doesn't know whether your tool could be in the Y axis, it could be in the X axis.
Which for a 5th axis machine, I guess, is quite important.
Yeah, 100%. And you need to know where your data points are. So now, if I go into test run, what I'm going to do is I'm going to create my file, bring up my file. So I'm just going to go to last files, because I haven't got time to waste searching through all my documents.
Oh, okay. So it's just right there.
Yeah, your next one is there. So you press enter.
Yeah.
So here is our block form. So 150 by 150 by 50.
It's almost like a CAD system, this, isn't it?
It's a very, very simple system, CAD system, right? Yeah. And if you're doing basic milling that doesn't need a 5-hour tool path, this Heidenhain is great to be able to get trained up on. So what we're going to do now is we're going to create a pocket in the middle. So we've got 150 square. So let's do a 50 by 50 pocket in the middle. Brilliant. So we'll go back to our programming, and we'll come across, bear with me, cycle def, okay? So we've got your drilling pockets.
Can I press this one?
Yeah,
now?
push cam.
Pockets.
Yeah, so this is brand new to you. So what we've got is we've got a square pocket, circular pocket, a slot, an angled slot, and then these 3 here are studs. So we're clearing out. So what we're going to do is we're going to go for this. Okay, so these are all this is all the information that this machine needs to create this pocket. So we're going to do roughing and finishing, roughing, or just finishing. So we could go in with roughing, and then we could come in with a different finishing tool just by copying this piece of information. We're going to do roughing and finishing. We're going to do roughing and finishing as 1. So we'll leave that as 0. Yep. So your first side length. So we said we were going to do 50 by 50, weren't we?
Yeah. Okay. So let's stick 15 there.
Yeah. Second side length, and as you can see, these Q numbers.
Yeah, so they tell you exactly what they need.
Exactly, and it's so user-friendly. So we'll put 50 in there.
How many times have you taught this?
Oh God, I used to go around the UK. This is what I used to teach. It used to be either 3-day training on the computer. I bet you got sick
of seeing this screen then, didn't you?
I'll tell you what, it's quite nice to come back to it. So your corner radius, we'll leave that at 0. Allowance for side, we'll put 0.5 because we want to come back in and take the other bit off.
I guess if you leave it at 0, your corner radius is the radius of the tool.
Is the radius of the tool, yeah. If you've got sometimes on your drawing you might have a 5mm radius, 10mm, but your tool will always correspond, because you can't have a 10mm with a 5mm radius, can you? It's not going to be able to get into the corners. So angle of rotation, if we wanted it like a diamond shape, we could 45 degree it, but we're going to keep it at 0 because we want it square. So pocket position. So say this is our piece of material. I want to put that datum point bang smack in the middle. So the pocket position is going to be 0. If our pocket was here, we'd pick 1 to correspond it. It's so user friendly.
It is, and I can see if we're on quite a complex 5-axis machine here, but I think it's set up to be versatile, so that if you want to do big complex 5-axis jobs with OpenMind or some other CAD systems are available, you can do. But if you want to just do a few jobs and knock up a few blocks here and
100%.
there, you just do it on the control.
100%. If you just got some facing off or some drilled holes, tapped holes, this is a great system for you to just be able to go on. And we're showing people at home how quick and easy it is to just create one singular pocket. So feed rate for milling, 500, that's fine. So which way are you going to climb? Are you going to climb mill, or are you going to...
Climb, we're going to climb mill.
That's nice for our tool, all right?
Yeah, exactly.
So how deep do you want to go?
I guess 20 mils good. I mean, it's already 20 mil. There's some sensible defaults in here already.
Yeah, 100%. So as you can see, it's minus 20 because we're going into the material. So you're plunging depth. So how far do you want to plunge
down
in?
every time you go down.
So it's going to do 5 mil. If you've got a big beast of a tool...
I was going to say these are some big fat WNT
so
cutters, so I think we can go 15 mil.
Okay, 15.
Problem is, though, if you go 15 mil, then you've got 5 mil little step you've got to take out again. So
but that's what you, as a tool manufacturer, you need to liaise with. So now we're going to go 20 mil depth. Plunging depth obviously means you step over. So you're going to do 5 mil, then 10, go down to 10 mil, 5 mil, step over, then down to 15 mil.
So we're going to take 4 cuts in the depth. Let's do it in 2 cuts. Let's do 10 mil.
Fabulous.
But if you've got an allowance for the floor, then obviously you're going to be taking 10 mil once.
But it will take that into consideration.
9.8 mil afterwards.
100%. So allowance for floor, leave 5 mil on, sorry, not 5 mil, 0.5 mil on there. Feed rate for plunging, 150. So it's going to be moving 150 millimeters per minute while it's plunging into that material. So you're in feed for finishing. So where do you want to go? So we need to go to 0 because that's going to go to the size of our pocket. So we've left 0.5 on, so it's going now to 0. Okay?
So that's in the Z-axis. See, I think that's okay.
So this is in across your sides.
Yep.
So this is your wall finishing. Okay?
Right, okay.
So the setup clearance. So once it's finished, it will automatically go up to 2 mil above. I like to change that to 5 because it's
2 mil's
more
not very
to
much,
see.
is it?
Yeah, you can set that to 50, you can set that to 100, so it can shoot straight up. Okay. Surface coordinate. So where are we starting? If you've got a bit of material that's got a ruggedy edge on the top, we haven't face milled it at the minute. Yours might be 2.5 mil over. So if it is, we can put 2.5 in. But for instance, we'll say it's all flush, so it's 0.
We're all set flat.
Okay. Second setup clearance. So obviously we set it at 5. This is now 50, so it will go to 5 mil and it will shoot up to 50. Okay. Tool path overlap. So this means it will come round and it will be...
This is like your step over.
Yeah, so we'll keep that at 1.
Okay.
Your plunge. So this is really nice that I like. So we can go straight in, we can helical in, or we can ramp it in. So I like to helical in, which is automatically a bit on there.
Which is great. You don't normally get those kinds of options on programming on the control.
If you didn't, you'd have to work it all out in your head. So it's coming down this much a minute. So this is the angle that it is, and it's like
that'd be quite complicated to do. GO2s moving down, GO3s.
Now what we're going to do is finishing feed rate, which is fine. Feed rates. So as you have a look, you can see all the different options that you can have. Okay, so you can even send the tool the other way round to finish it up. But what we're going to do is we're going to stay at 0 because it's recommended. Okay. So now what we're going to do is we've told the machine we're going to do a pocket, but now we need to tell it to do the pocket. Yep. Also, I haven't picked a tool yet. So what I'm going to do before the pocket, because I always like to pick the tool, then pick the pocket. Yep. So we're going to go tool call, and we're going to pick select.
From our tool table.
So what, should we use a 16 mil?
I think 16 mil should be all right. Leave a 60 mil, an 8 mil radius in the pocket.
Lovely.
Pocket corners.
So we've got number 7.
Yeah.
So if we click that, so the tool is now going to be in the Z axis. We can change that if you have a different machine where your spindle's on the side, you can change it to X axis. So your speed, what spindle speed should we do?
I don't know, 3,000.
Okay.
If you want, you can put in your cutting speed as well.
Yeah,
so actually, if I go
You carry on.
Choose
Look at
the
this.
cutting speed.
It's only been on
let's
it 5
say
minutes.
in aluminium, I guess 220
Yeah.
should be all right, depending on whatever the cutting tool manufacturer says. If we hit, and
Okay,
that's it,
press
if we hit
enter.
End, I'll enter.
Okay,
Yep,
so we
sweet.
need a feed rate in there.
1500. I don't know, it might be a little bit quick. I don't know. We'll see.
Okay,
And
your
then-
DL means have you got any tools that you want to oversize? We don't, do we? We don't want to
No.
add anything to it.
So that's
And then
okay.
it'll come up with DR.
There's loads of
There's
different options
loads
there.
there.
Fantastic. So if I hit
Okay,
in,
so
oh no, I just hit in there.
no. See, he's going too quick now.
I'm pressing too many
So
buttons.
we tool called, right? So that tool will now come into the spindle. It's read that it does a rectangular pocket, but now we need to tell it to perform that cycle. So what we're going to do is we're going to do cycle call. Okay, I like cycle M.
What do we have to do next? Is it cycle call by any chance?
Yeah, 100%. So we've defined the cycle. We've told the machine what cycle we want to do. So now if we go to cycle call, we're calling up that cycle. So we're going to do cycle call M, and then we're just going to end it. Okay, so we're calling up that cycle. We go reset and start. You can see.
We just simulate. Oh, right, so you can simulate the
Yeah.
pockets. Oh.
There we go. So we've got 150 mil material stock, haven't we? And as you can see, we can see our little pocket, our big 50 millimeter pocket being done. So this is in your programming status. So this will give you a 2D example of what's going on. But if we go into our test run, you can see how we've got our tool call, our cycle def, cycle call. So if we reset and start, I've done a pocket, but I haven't defined.
Oh, you've not just set where it's going to be.
Where it's going to go.
It needs to be at 75,
So this is
75.
great because if something goes like this happens, we haven't ran it on the machine, and that if you're working in a machining shop, you told your boss this, why didn't you check it first? This is a great way to reduce errors. So what we need to do is we need to move the tool into 150 divided by 2, so 75 x 75. So what we'll do is we go back in to here. We've called our tool. So then what I want to do is I want to create a line.
Yep. L.
Lovely.
Bang.
Okay, x 50.
Yep. Or 75.
Oh, 75,
Yeah,
sorry.
no, we're doing
Good
it,
maths,
yeah,
quick
75.
maths. Enter.
Y 75.
Oh no. So if you come back and then just
there
go
we
across.
Oh, and then click Y.
75.
Perfect.
Go
And
across.
enter. Oh, then do you want to pick a...
Always go across.
Ah, right, okay. Then you want
Because
to pick...
if you press enter, it will just give you the X coordinate. If you go across, it will give you the
right,
Y.
okay. So when you go Z,
Go
50?
50. Yeah.
Okay.
Go across.
Across, yeah.
Okay, so on here, because we've got a 5 axis, we've got a B axis as well.
Yeah.
Okay, we don't need that. We don't need
radius
radius
comp?
compass. No, we don't,
No.
because the compensation comes on in
the cycle.
In the cycle,
Okay,
yeah.
fair enough.
So we've got a feed rate, so we can do F max.
F-max.
So that's
Let's
as
do it. Let's
fast
wrap
as
it
a
down
machine
there.
can go.
Sweet. Do you want to call any coolant or
So if we
anything?
put M13, what
Yeah.
that will do is it will let the spindle go clockwise and it will turn the coolant on at the same
okay,
time.
perfect.
So if we press end at the
Yeah.
end of that, I wanted to quickly do another line
Yeah.
for me.
Okay.
And I want you to scroll across with your arrow and just
Yeah.
go to Z.
Oh. So in the line
That's it, keep
and
going.
hit Z.
Yeah, and then just go to Z10.
So then we're going to come across those 75, Y75.
We're gonna come down to Z10.
Cool, and hit end.
Yeah, so you can put that as
hit
F max as
F-max.
well.
Sweet.
Okay, and then we defined our cycle. If you press N now, sorry, Rowan.
Yeah.
If we go to reset and start, if we always go to the top of your program, press reset and start. You can see now.
We're going from
It's
machine
moved.
coordinate 0 up to...
Yeah,
Nice.
there we go. So we moved right out there. And also what we can do is that zooms in, that zooms out. Okay, and you can go 1 to 1.
Brilliant.
So
So
we
should we
moved-
have a look at the simulation?
Yeah. So
Check
go
we've
into
actually got
test
them
run.
right. Yeah. Reset.
Reset and start.
Hey, there we go. So now we're cutting
How
the
lovely
pocket
is
right in
that?
the middle. Easy.
So that just goes to show how quick and easy it is to run a Heidenhain program.
But even I can do it.